Welcome back, everyone. This is the second in our series of webinars looking at the changes between the version 8 and version 9 of the Australian curriculum in the area of digital technologies. And I'm pleased to be welcoming back Bruce and Paula. In our first in the series, we did a bit of a lengthy intro to who we were, and we also gave a bit of a guided tour of the version 9 Australian curriculum website. So we won't be doing all of that again this time around, but if you do want to hear more about us and about the Australian curriculum, then please do refer back to the first webinar in this series. But today, the area that we're looking at is data, and Victorian teachers would possibly group this under what we find in our state curriculum, where it is called data and information strand. But that's most of the content that's in there. What's happening with this area in the Australian curriculum now? So I'll hand back to Bruce again to take over from here. Thanks, Bruce.
No worries. And in the first talk, we spent a little bit of time talking about some of the broader changes in the Australian curriculum. They're here on the slide. I won't go into a lot of detail here, but as Nathan said, you can always go back to the first webinar in the series to hear a little bit more about some of these and the impact they're having on digital tech. What we are going to focus on, though, is the concepts that are actually captured through the various aspects of data in the Australian curriculum. So the learning area of technologies has two concepts, data and computational thinking, that are very strongly linked to what we'll be talking about today. But the specific concepts in digital technologies that we tend to cover when we're doing data-related things are abstraction, data representation, data acquisition, and data interpretation. So, together, they sort of capture everything that appears in the data strands, for want of a better term. I probably shouldn't use that because in the V9, it's knowledge and understanding and process of production skills. But, we like to think, at least from a writer's perspective, about concepts and how they flow through the subject area. And so those four concepts are the ones we really sort of focus on when we're talking about data in version 9. So there have been quite a few things that you need to be aware of. First is that the location of a lot of the content related to data collection and interpretation in particular has been removed for primary school, and we'll focus on that a little bit later on. There have been minor changes to data representation throughout, some of that clarity, some of that refinement, some of that minor updates, and there's been a lot of refinement in the language used in the high school content descriptions. So let's talk a little bit about what's happened in primary first. There are now no content descriptions at all in years F to 6 for data acquisition or interpretation. Instead, a lot of it is now present inside mathematics, and that's all rolled into the statistics strand in maths. And we'll look at some examples of how that has come about a little bit later on today. The other big change is that binary concepts have now explicitly been mentioned in years 5 and 6. Now, this is a very simple version of binary. It really is just that idea that something can have, two values, true, false, 1, 0. It's not something that there is extensive use of, but I guess it really links nicely to that idea of having a condition associated with an if statement or a loop. So it's just instilling in students that idea that there is this idea that something can have one of two values, and that can be useful.
Just on what Bruce mentioned there about mathematics, so we will also touch on some of the related mathematics content descriptors towards the end of this segment, so that we're not leaving that out, but we will mention a couple of those mathematics ones at the end, so that you can see where that link is now.
So in addition to that refinement that I mentioned, there is a lot more cleaner and direct, the language that's used in the content descriptions. And as I mentioned in the previous webinar as well, there's been a lot of breaking up of compound content descriptions into separate statements. And that's really improved the clarity and the expectations that teachers need to understand, so that hopefully I think everyone will find that a lot easier to navigate and turn into learning programs. We now mention data modeling explicitly, and that provides a lot more clarity too around what we mean when we talk about structured data. So we'll come back to that as we look at what that looks like, particularly in Year 7 and above. And the other thing that's being done, and this is kind of related to the digital literacy connections that we mentioned before, but there is now explicit reference to spreadsheets and databases inside the content descriptions so that you can get a sense of when those tools should be introduced and how they should be used. And I think that's going to go a long way in ensuring that teachers know what we mean when we're talking about things like what I mentioned, structured data, or organizing or collecting or interpreting data, and how far that should go in each band. So we're going to dive into the content descriptions again. As before, we're going to have a look at how they've been split apart, how they've been updated, and have a look at some elaborations. Now, our first is data representation in Year 5-6. In the old curriculum, we had whole numbers used to represent all data in digital systems. You can see now that we've still got that there in how digital systems represent all data using numbers. It's a little bit nicer now. It's a cleaner statement. But in addition to that, we have this new content description around binary. So often on states or zeros and ones. And so this elaboration really demonstrates that what we're after is just that idea of on and off. You can talk about that in the context of circuits if you want to link it to science, and just make sure that students are aware that that representation of data is actually important for broader digital technologies. In 9 and 10, we had this compound content description before, where we had simple compression of data and how content data are separated from presentation. That was a really difficult content description for most people to parse. So you can see in the new version where that's been broken apart, we've got a very clear statement about the separation of data. You can see there content structure and presentation. So a really clear reference to potentially using something like web development, HTML, CSS, and JavaScript as a way of exploring this idea. And then you can also see that the data compression side of things is something you can look at in isolation. So just looking at the techniques we can potentially use to compress data, and note that this doesn't have to be, overly formal, and we're not going into, very complicated technical explorations of that. In fact, if we look at the content description and the elaborations for that one, you can see here we're talking about things like run length encoding, talking about what the consequences of lossy and lossless compression are, and understanding what the implications would be then, depending on how you're using that. And looking at ways that you could potentially use the structure of the data itself to inform a potential compression algorithm that you might then want to implement. You don't have to write it, but you have to think about, the different properties of data that would lend themselves to some sort of compression technique. When we look at data interpretation, this is all the analysis and visualization of data. We used to have this statement in Year 7 and 8, where there's a reference to structured data to model things after the analyze and visualize. These have now been separated. We've got a clear link to spreadsheets and databases that's been pulled out, and what the expectation of the analysis is, which in Year 7 and 8 is that idea of being able to draw a conclusion and make a prediction by looking for trends in data. And then separately to that, the modeling and querying of data is, pulled out on its own so that you can understand that that can be a different task and doesn't all have to be bundled together into this one behemoth of a content description. And
Bruce, can I just, sorry.
No, go ahead, Paula.
No, I was just going to say that in Victoria, the VCAA published in term 1 a glossary of command terms, which spans from F to Year 12. And the words there of analyze and model, etc., are quite clearly stated now about what the expectations are. And I think when you look at these content descriptions, teachers in Victoria now have a really, really clear idea about what should be taught. And then from an assessment viewpoint, there should be more confidence in being able to know and measure the students' performance. So I think this is, it's worked really well. The splitting gives more specificity, so it increases the chance for more informed explicit teaching. but the other side of it is that it combines with the glossary of the command terms now and really assists teachers in knowing the teaching expectations as well as student performance.
Thanks, Paula. And so if we want to understand what we mean when we say model and query, the elaborations are now very, very explicit around what that is in year 7 and 8. And I think the big one to call out here is that when we're talking about querying databases in year 7 and 8, we're really just looking at single table databases. And students can do this either with visual tools, such as, the filtering tools that you might see in Access, or with simple SQL queries using, standard select, where, and order by clauses. And I think by really specifying that that is the extent of what we want from a querying perspective in year 7 and 8, we can sort of set the bar between what, a year 9 and 10 interaction with databases for students is like compared to year 7 and 8. The idea is this is a sort of a ramping up. It's an opportunity to sort of take a lot of what you may have had to teach in year 9 and 10 if you were doing databases from scratch and putting some of it into year 7 and 8 so that you're spreading out those expectations and exposing students to these ideas using a range of different tools. So, you can filter with spreadsheets, you can filter with databases, and you can talk to students about the differences between the two types of tool.
Just a note again, Paula and I were discussing earlier how currently, so if the new year 9-10 Australian curriculum does do some relational databases at year 9 and 10, currently our BCE applied computing curriculum in unit 1 and 2 only requires single table databases. So that's a potential implication for Victoria going forward as well, if we're going up to relational databases in 9-10, but then back to just single table ones in unit 1 and 2 of applied computing.
Yeah, and you could argue that with 9 and 10 potentially being elective in most parts around the country, that's in line with kind of, consolidating what students do in year 7 and 8 and then building on it. But that is definitely something that's going to have to be explored in Victorian context. We said we were going to have a look at maths. Here's an example of the old content description from digital technologies in year 2, where we had collect, explore, and sort data and use digital systems to present the data creatively. If we were splitting that up, you'd have 2 there, collect, explore, and sort, and then presentation as a separate one. When we look at how that's sort of appeared in mathematics, you can see here in the statistics strand, which is what the ST there indicates, you've now got these 2 statements from mathematics. And you can see that there's some sorting and displaying of data in the first statement there. There's understanding what the purpose of your representation and presentation is in the second one. So the content's still there. It's just present in different locations. And so if you want to understand what digital technologies, what the experience a student should have with data in digital technologies should be, then I think here's an opportunity in primary school to work closely with the general classroom teacher if you're a specialist, or if you're a generalist who's working across both, to really look at those relationships and take advantage of the fact that you now have a mechanism through which you can teach both subjects at the same time, as long as the emphasis is clear. And it's worth pointing out that whilst there is no content description in years prep to 6 for these things, if you look at the achievement standards and if you read the band descriptions for those levels, there's a clear reference to how data is expected to be used, because conceptually these content descriptions were intended to be shared between digital technologies and mathematics. And by taking them out of digital technologies, the intent was to reduce the duplication of content and to declutter the curriculum. Again, one of the goals of the version 9 review. And what we're seeing on the slide here is just another example of how that's been done, this time in year 6, where because the complexity of the original statement in digital technologies was a little bit higher, it's actually spread across 3 different statistics content descriptions in maths. So, all the maths content that was there remains, and the language from digital technologies is now more explicit in those maths content descriptions.
One other thing to mention too, and this segment is not about algorithms, but it's worth mentioning. Victorian teachers will know that in our state curriculum, the maths learning area does have content descriptors to do with algorithmic thinking and doing algorithms. This has been duplicated, or not duplicated, but it's also been addressed in the new Australian curriculum. The mathematics also has algorithmic thinking in it. So the implications for Victoria, not just algorithms, but also now what happens with data. Would we follow the Australian curriculum in kind of stripping it from the digital technologies curriculum so that it would be implemented in the maths curriculum, or leave it in both? Another potential implication is what happens with that binary being introduced at 5 and 6. And Bruce, I might get you just to what was the last one there about privacy, the most appropriate place?
Yeah, so if we have a close look at some of the privacy content descriptions, which we talked about in our previous webinar, what you'll see is that a significant number of them, or probably all of them, are really closely linked to data. And whether that's the personal data of the student or the data that you're collecting of people who are effectively going to be the users of the solutions you're creating, the fact that privacy is so tightly woven with data, and you already have a data and information strand in Victoria, the question really is, where should privacy live? Because there's a really strong argument that putting it in with data means that as you're talking about things like acquisition and filtering and identifying what data is going to answer your problem, you can have those privacy discussions. But privacy is also very tightly coupled to security. So, there are big questions, I think, about where the best place for these privacy content descriptions is in Victoria.
Any thoughts, Paula?
Oh, no, I do agree. I think there's the dilemma. There's the great advantage of having more ideas connected under one umbrella, like data and information. But, the other side of it is when Bruce is saying that data is everywhere. The students have got to put different hats on and look at data when it's in different categories. So it is a dilemma, and I'm certain that with further investigation from VCAA, they'll be able to come up with a solution as to the best fit within the curriculum document. But as we've been saying all the time, the trick is being able to stitch all of these elements together into coherent teaching and learning programs. So support needs to be given to show how we can join the dots. So when data is sprinkled everywhere, what are the various ways in which you can connect data in learning programs?
It occurred to me as we were talking about this, because data appears in humanities as well. In geography, you work with tables of data, and it occurred to me that data is almost starting to become a digital literacy thing, isn't it? It's starting to become something that you should be able to work with data no matter what subject you're doing. Sort of, it's almost like becoming something that's that relevant across so many areas, not just maths and digitech.
And I do
that's
think
where you get the. Sorry.
No, go, Paula.
Go on, Bruce. No, I was just saying that's where you get the notion about you have a common concept across a whole range of learning areas. And I think the trick in all of this in these programs is to distill the concepts from each one and say what at the end of the day is common, but what is peculiar to each of those learning areas. And the real important thing is that for each of the learning areas, the integrity of that perspective is respected. So there is a body of knowledge and skills that's shared. And it's really good if we can, distill that, get the essence of what it is, say, about data, but then say, yes, we know when you view this in geography, this is the lens by which or through which you do it. This is what you do in science. This is what you do in maths. So I think that it's a critical way to be able to make connections, but we must preserve the integrity of each of the learning areas.
Yeah. Sorry, Bruce, were you going to add something?
No, I think we'll leave it there, and instead, what I might do is do a summary, do the TLDR summary of these topics today. So, big one for data is remember that it's no longer in digital technologies in primary. So you're going to have to look at mathematics to understand how those expectations will fit in with the other parts of the curriculum. There's been a significant improvement in the clarity right across the board, so that should help you understand what the expectations are, particularly, as I said, pulling the modeling out from the actual analysis so that those are clearer, and taking a look at the elaborations to really make that tangible and think about how that may align with some of the things you're already doing in the class, or how some of your existing lessons could be tweaked to take advantage of what the intended examples described in the elaborations are. I think will make this a much better version of the curriculum to be working with.
Well, thanks everybody, and we'll be going on to our next session in the next segment, which is all about algorithms and the user interface, user experience concepts as well. Thank you.